So this video is integrated 3, chapter 3, D-Day number 3, getting us ready for our chapter 3 test and our chapter 3 group quiz. So on this first problem, this is a system of equations that are linear. Both of them are linear. And we're going to use elimination. We're either going to try to get the same number in front of our x's or the same number in front of our y's, but we want different sides. I think I'm going to lean towards my y's because one of them's already negative and the other one's positive. And so if I have a 2 and a 3, I'm going to be trying to get a 6, a negative 6 here and a positive 6 here. So what I'm going to do is I'm going to multiply the top equation by 3, which is going to give me a 9x minus 6y is equal to a negative 51. I'm going to multiply the second equation by a 2, which is going to give me an 8x plus 6y is equal to a 34. I'm going to add these two equations together. And when I do, I'm going to end up having this become a 17x. These are going to cancel out, is equal to, and a negative 51 and a 34 is going to be a negative 17. And so I'm going to get x is equal to negative 1. So I know it's going to be negative 1 comma something. I need to take this x, substitute it into either equation to get my y. So let's say I'm just going to do it to the second equation. It doesn't matter which one. So 4 times negative 1 plus 3y equals 17. So negative 4 plus 3y equals 17. 3y is going to equal 21. So y is 7. So I get a negative 1 comma 7. And that is my point of intersection. On B, this is going to be a square root graph and a linear graph. I'm going to use equal values because they both equal y, so I'm going to set them equal to one another. Okay, so when I do that, I am going to get the square root of 24 minus 5x is equal to 2x plus 3. When I have a square root, we consider this a principal root. It has to equal a positive or 0. It cannot be a negative. And I don't know what this is. So over here, afterwards, I need to check, and this can't be negative. Okay, I also can't have a negative underneath my square root. Okay, so let me just rewrite this problem. So I am going to have the square root of 24 minus 5x is equal to 2x plus 3. I am going to square both sides here. And when I do, I'm going to get a 24 minus 5x equals, and remember, this is going to be an a plus b squared, okay, which is a squared, multiply together and double, so 2ab plus b squared. So in our situation, I square 2x and I get a 4x squared, plus I multiply these together, I get a 6x, and I double it, I get a 12x, plus when I square 3, I get a 9. So I want 0 on one side, everything else on the other side. So I'm going to have my 4x squared. I'm going to be adding 5x to both sides. I get a 17x. I'm going to be minusing 24 from both sides. And when I minus 24, I end up getting a negative 15. So now I'm going to factor this. So I am going to do a box to diamond. So I have a 4x squared and a negative 15, which is a negative 60x squared, has to add to this 17x. And I need to figure out what multiplies to a negative 60 and adds to a 17. And I'm thinking 20x and a negative 3x. So a 20x and a negative 3x. Now, I'm focusing on this 4x squared. That could be a 4 and a 1 or a 2 and a 2. But with this 20 here, this could be 2, But with this -3 here, this can't be 2, so it can't be 2 and 2. So it's going to be a 4 and a 1. I need the 4 here giving me the 20, the 1 here giving me the -3. So this is going to be a 4x and an x. 4x times 5, so this is going to be a +5. X times a -3. So I'm going to have a 4x minus 3 and an x plus 5. And so I'm going to get a 3/4 and a -5. And remember, I need to check those up here to make sure that that does not make 2x plus 3 a negative. The 3/4 will not, because everything's positive. The -5 will, because if I go 2 times -5 plus 3, I get -10 plus 3, which is -7. So this one here is not going to be an answer. That's an extraneous solution. Now, that is my x. I need to still find my y. So when I put that in there, so I do have to actually work it out. 2 times, let's say 3/4 plus 3. So that's going to be 6/4 plus 3. Okay. So I'm going to end up getting 3/2 or 1.5. So this is going to end up giving me a 4.5. So I'm going to have a 3/4 or a 0.75, comma 4.5 as my point of intersection. Again, 3/4 is the same as a 0.75. Okay, on to solving a system, and I'm doing it with graphing. So this one here, I'm going to do it in blue. So my y-intercept is a -2. Okay, and then I am going to go up 1, 2, 3 over 1, 1, 2, 3 over 1, down 1, 2, 3 over 1, get my line tool, draw my line. Okay, and that is my line. Now I am also going to graph the other line. So that one, let's say I do it in red. So that one I'm going to start up at 5. I'm going to be going down 1 over 2, which actually makes this point right here be one that they have in common. Let me just kind of highlight it. So this point right there, okay, that one right there. Okay. So I'm going to continue down 1 over 2, get my line, draw it out. Okay, and then you have to give your answer to what is the point of intersection. That's the point of intersection. That is at 2, 4, and that's my solution. That's where the two graphs are the same at the same time. Okay, on B, this is a system of inequalities. I need to graph and shade. So let's say I do orange for the first one. So this first one is a square root graph. Okay, so let's say I do this one in red. So for this, I am going to start at my starting point, okay, which is going to be -2, because that's what makes the square root 0. Okay, -2, comma, -1. So I'm going to start at -2, comma, -1. And then from there, it's a square root. And so as I go out one, the square root of one is one, so I'm gonna go up one. As I go out 1, 2, 3, 4, the square root of 4 is 2, so I'm gonna go up 2. If I went out 9, so that's 4, 5, 6, 7, 8, 9. The square root of 9 is 3, I go up 3. And then this is going to be a solid line because this is less than or equal to, or solid curve, I should say. So I'm going to draw my curve. And then it is less than or equal to, which means I'm going to shade below. So if I come here, I'm going to shade below. And then everything to the left of this isn't going to make sense because that's going to be a imaginary number. So this right here is kind of a boundary line for square root graphs because again, I cannot take the square root of a negative. So anything to the left here of -2 would make this be the square root of a negative, which would be imaginary. So this goes below this line, but it actually is also bordered by this line right here. Okay, so the other one, let's say I do it in blue, okay? And so this one, it has it's a parabola. It's going to have a vertex at 3, -2. So I'm going to go 3, -2. So this gets a little fatter. Okay, so 3, -2. Okay, that's my vertex. And then it is a parabola with a stretch of 2. So from here, I'm going to go out 1. 1 squared is 1, double that, so 2. And it's going to be the same on both sides. If I go out 2, 2 squared is 4, double 4, it's going to be up to 8. So 1, 2, 3, 4, 5, 6, 7, 8 is going to be off. Okay. Now this is going to be a dash because it says greater than, doesn't have an equal. So let me just come and get my dashed and let me draw it. I'm going to start again. And then for this one, I am going to be shading greater than, so it is going to be above. So if I come to my vertex and I go up, you see I would be inside of this. If I went to my vertex and I went down, that's less than. You see I'm going to be under, but I'm also going to be outside. It's really everything out here. So again, we want above, which is going to be here. So let me shade that. So it's going to be everything here. And then you see where the purple is. I'll emphasize the purple a little bit more. Okay, so where the red and blue make purple, this right here, everything here is where my solution is. So I'm just going to write answer here so that we know that this region right here, that is going to be my answer. Any point in there is going to make this system true. Okay, on 3A, I'm solving this. So I'm going to add 11 to both sides. And so I'm going to get a 48. I'm going to divide by 3. I get a 16. I'm going to square root. And when I square root, I get a positive and a negative. So I'm going to have a 7 plus or minus 4. So that means 7 plus 4 is 11. 7 minus 4 is 3. Those are my two solutions. On B, I'm going to get everything on one side, 0 on the other. So I'm going to minus 9, which is going to give me a negative 20, minus 24. So when I factor this, this is going to become an x plus 8, x minus 3. So I have a boundary point at -8 and a boundary point at 3. So on my number line, I am going to have a -8 and a 3. It is going to be closed dots because of the less than or equal to. Okay, less than or equal to right there. So it's going to be included, and I want less than or equal to. So the way I think about this, I could test a value here and here and here and see what makes it true. But this is a parabola. And I think of this number line as this is where my graph would touch the x-axis, where it's 0 at -8 and at 3. And I want where it's less than. So this would be an open up parabola. So I'm going to start above. And that means as I'm coming here from the left to -8, I'm above, which is greater, at, below, at, above. Okay, let me draw that a little neater. Okay, I was just trying to have you follow. So when I'm doing this, again, right here, this is going to be above, which is greater. Same with over here, this is above, which is greater. And here, you see I ended up below the line. I want where it's below. So I'm going to be shading in between like that. Let me just redraw my graph a little neater. Okay, so that's kind of like my working graph. So I'm going to have -8, 3. I'm going to have a closed circle at -8, closed circle at 3, shading in between. Okay, that's where my parabola would have been below the x-axis, or it would have been less than or equal to 0. Now, to write this, I'm going to start with -8, less than or equal to x, and still less than or equal to 3. That's my graph and my solution. On C, I am going to be trying to isolate my absolute value. So I'm going to have 3 absolute value of x plus 4, add my 1, I get a 15. I am going to divide everything by 3, so this is going to be a 9x, and this is going to be a 5. Now, absolute values also have to be equal to not a negative, so this can not be negative. So we're going to have to check our answer. So I'm going to work out 2 equations. One of them is going to be x plus 4 is equal to 9x plus 5. The other one's going to be x plus 4 is equal to a negative 9x minus 5. So I'm going to subtract x. I'm going to minus 5. And I get a negative 1/8 as a possible answer. The other one, I'm going to add 9x to both sides and get a 10x. I am going to minus 4. So I get a negative 9. And I get a negative 9/10. So I need to check both of these up here and see if they make it negative. If they do, they won't be a solution. So 9 times a negative 1/8 plus 5. If I put that in my calculator, 9 times a negative 1/8 plus 5, I got a positive 3.875. So this one is going to be an answer. And when I take 9 times a negative 9/10 plus 5, so 9 times a negative 9/10 plus 5, I end up with a negative 3.1. So that one is not going to be an answer. So only negative 1/8. Okay, on D, what we're going to do is we need to get, first off, I'm gonna let u equal the square root of x plus 1. So I'm gonna rewrite this as 3u squared is equal to 27 times raised to the 4u. Then I want to get this 3 and this 27 to be the same base. So 3 to the third is a 27. Okay, so I'm going to rewrite this. I have 3u squared is equal to, and 3 to the third is a 27, and that's raised to the power of 4u. So power to power, I'm going to multiply, so it's going to be 3 to the 12u. And when they're the same base, I can take the exponents, set them equal to each other. So I'm going to minus 12u from both sides. I'm going to factor out a u. I get a u times u minus 12 equals 0. So one answer for u is 0, the other one is 12. But remember, u is the same as the square root of x plus 1. So let me rewrite this. So I'm going to have the square root of x plus 1 equals 0, and the square root of x plus 1 is equal to 12. Okay, so again, this is a square root, so I need to make sure that this is not negative, which it's not, so that's okay. Same with over here. Okay, so we're okay here also. So I'm going to square both sides here, and I get x is equal to -1, that's one answer. I'm going to square both sides here, so I get x plus 1 is equal to 144. So x is equal to 143, and that's my second answer. On E, I have a square root equal to this, again, can't be negative. Okay, so I am going to have a 4 minus 2x is equal to x plus 1. I am going to square both sides. I saw this earlier, so this is going to be a 4 minus 2x. This side I'm going to square. So it's going to be an x squared. I'm going to multiply together and double. So that's going to be a 2x. And I'm going to square 1. I am going to add 2x to both sides. I'm going to minus 4. And so I'm looking to see what multiplies to -3 and adds to a positive 4. So multiplies to a -3 and adds to a positive 4. So it's just a 3 and a 1. So that is not going to work to factor. So what I'm going to do, I am going to complete the square. That's what I'm going to do. So I am going to subtract 3 from both sides. And then what I'm going to do is I need to figure out what would make this a complete square. So I take my b, which is 4. I take half of it, which is 2. And then I'm going to square that, which is 4. So I'm going to add 4 here and also to this side. So I'm going to get a positive 1 is equal to, and this is going to be half of 4 is 2, so this is going to be x plus 2. I'm going to square root, so I get a plus minus 1 is equal to x plus 2. I am going to, let's just double check my math here. Oh, this is going to be a positive 3. I apologize. Positive 3, positive 3. Okay, so this was a -3 here. So when I take it to the other side, it's a positive 3. Okay, that's my mistake. So this is going to be a 7. So now when I take the square root, I just knew I wasn't going to supposed to get nice numbers. I'm going to take the square root. I'm going to get a plus or minus root 7. So my answer is going to be 2 plus or minus root 7. And when I go 2 plus, when I do 2 plus root 7 plus 1, that's going to be okay. And then when I do 2 plus roots, 2 minus root 7 plus 1, let me see what sign that will be. So 2 minus root 7 plus 1 is going to be positive also. It ended up being a positive 0.354-ish around. So both of these are answers, but you do need a check. Do need a check. Okay, on 4. So for this, I am going to add 17x. I am going to see if I can factor this. So this is going to be 2x squared and a 21. So that is a 42x squared and a 17x. So that is going to be, let's see. So 1 and 42, 2 and 21, 3 and 14. So let's see, 3 and 14 is going to give me a 42, and that actually adds to 17. So I'm going to have a 3x and a 14x. And on the outside, I'm going to have, let's see, 2x here, x here, plus 3, plus 7. So I have a 2x plus 3 and an x plus 7 less than or equal to 0. So this is going to be on a number line. I'm actually going to draw this twice. So this is going to be a negative 3/2 is going to make this 0. A negative 7 is going to make this 0. So let me actually adjust this. This will be a negative 7. This will be a negative 3/2. I am going to copy this and put it here. That part. Okay. So this will be a negative 7 and a negative 3/2. So again, I'm going to do it where I think about it as a parabola, as an open parabola. And so I'm going to be coming above like this. Okay, now what are we looking for? We're looking for it to be less than or equal to 0. So this is where it is 0. And those are going to be solid dots. And then I want it less than, so less than means below. So I'm going to be here because this one here is above. And this is here is above or greater. So I'm going to be in between. And the way I'm going to write this answer is negative 7 less than or equal to x less than or equal to a negative 3/2. And that's our answer. On B, this is an absolute value. So I'm going to times both sides by 3 first, just to get rid of that 1/3. So I'm going to have the absolute value of x plus 7 is greater than 15. And so I'm going to do x plus 7 equals 15. X plus 7 equals a negative 15 to get my boundary points. So I'm going to get an 8 and I'm going to get a negative 22. So I am going to have negative 22 and 8, and I am going to have this twice. Okay, I'm going to do it twice, once as a working graph and once as a final answer. Okay, so when I'm doing this, I want where it's greater than, strictly greater, so that means open circles. Okay, and then this is an absolute value, and an absolute value is a V-shaped graph. So I'm above, at, below, at, above. And you might say, oh yeah, but this is not supposed to be greater than 0, it's 15. Yeah, think of this as a height of 15. So this right here, I'm above 15. Here I'm below 15, and here I'm above 15. So I want it to be greater than or equal to 15. So that's going to be on the outside. Okay, on the outside. And so this is going to be x is less than negative 22, or, and you need the word or, x is greater than 8. And that's my graph and my solutions. On number 5, we're converting this to graphing form by completing the square. So this one here, it's going to be, I'm not going to have an a looking at this equation, so it's going to be an x minus h squared plus k. This is going to be a circle when you have an x squared and a y squared. So a circle is x minus h squared plus y minus k squared equals your radius squared. So for the first one, I am going to minus 3 from both sides. I am going to leave myself a space here. And this is going to be x squared minus 8x. And again, I'm going to be adding something here. So I'm looking at this negative 8. I'm going to take half of negative 8, which is negative 4. I'm going to square negative 4, which is a 16. And so this is 16, this is 16. So I'm going to have y plus 13 is equal to the quantity. And when I have x squared minus 8x plus 16, half of that negative 8 is a negative 4. So that's what goes here. And then I am going to minus the 13. And so I'm going to have the quantity x minus 4 squared minus 13. And that is your answer. On the next one, same idea, but I am going to have my x squared. So x squared plus 10x. Let me group that together. Plus something. Plus, and then I'm going to have y squared minus 4y plus something. Move it a little bit. Is equal to 3. So I'm going to take my b, which is 10, divided by 2, which is 5. And then 5 squared is 25. 25 here, and that means I'm going to add 25 here. My negative 4, I'm going to take half of negative 4, which is negative 2. I'm going to square negative 2, which is 4. So that's going to go here and here. And then when I'm writing this, this x squared plus 10x plus 25 is going to be half of 10 is 5. So this is going to be an x plus 5 squared plus, and then this is going to be a y, and then half of negative 4 is negative 2, so minus 2 squared. And then when I do that math, I'm going to get 31, 7 plus, sorry, 32, because it's a 7 plus 5, so 32. And that's our equation for circle. Okay, on number 6. So on this one, I'm going to have 3 inequalities. This red one here, the y-intercept is 3, and it looks like I'm going up 2 over 3. So this is going to be y. It's going to be less than or equal to, because I'm shading below it. Okay. A 2 over 3x plus 3. The blue one, my y-intercept here is at negative 2, and it looks like I'm going down 1 over 1, 2, 3, 4. So down 1 over 4, and my y-intercept is a 2. And for this one, I'm shading above it, so that's going to be greater than or equal to. And then for my green one, my y-intercept's a 4. I'm going down 2 over 1, so that's going to be a negative 2x plus 4, and I'm shading below, so this is going to be y is less than or equal to. And that is my system. On 7, setting up a system of equations for this, I am going to let b equal cost of burrito, and t equal the cost of a taco. And then I'm going to translate. So one equation, 7 burritos and 3 tacos cost $25.66. So 7 burritos plus 3 tacos is equal to $25.66. The second equation, 4 burritos and 2 tacos is $15.22. So 4 burritos and 2 tacos is 15.22. So I either need to get the same number for my B's, which would be a 28, or the same number in front of my T's, which would be a 6. I think I'm going to go with the 6. And let's say I multiply the top equation by a 2. So let's multiply the bottom equation by a -3. Okay. So the top one, I am going to get a 14b plus 6t is equal to, and 2566, 2566 times 2 is 5132. And then this is going to be a -12b minus 6t is equal to, and a 15.22 times a -3 is a -4566. I'm going to add the two equations together. I'm going to get 2b, my t's are going to cancel out, and 5132 minus a 4566 is a 566 divided by 2 is going to give me a 283. So the burritos are going to cost $2.83. The tacos, let's say I put it in the blue equation. So 4 times 283 plus 2t equals 1522. So I end up getting an 1132 plus 2t is equal to 1522. I end up with 2t's equal to 390. And when I divide by 2, I get $1.95 for a taco. Okay, even and odd. So I'm going to put in a -x and see what happens. So I have a -x squared minus 3 times a -x to the 10th plus 16 times a -x. Remember, if I get this exact same thing back, that would be even. If I get the opposite, this would be the opposite, then that would be odd. So let's see what I get. So this is going to be a positive x squared. And this is a -3 times a -x to the 10th. Sorry, a positive x to the 10th, because a -2 and an even is going to be a positive. And a minus 16x. So if I clean this up, I'm going to have x squared minus 3x to the 10th, which almost looks like this, but I'm going to have a minus 16x. And that's not the opposite. So this is going to be neither. Okay, so when I compare it, it needs to either be the same or opposite, and I didn't get either one. X and Y intercepts. So the x-intercepts, what I'm basically going to do is I'm going to put 0 in for my x's, so that's going to be gone, that's going to be gone, that's going to be gone. And so my y-intercept is going to be -6/2 or -3. Now, when I'm trying to find my x-intercepts, I want this to be equal 0, which basically means I want my 5x squared minus 7x minus 6 to be 0. So I am going to factor. So I have a, let me make this a little bigger, a 5x squared and a -6, which is a -3x squared, has to add to a -7x. So that's going to be a 10, a -10x, and a 3x. So -10x and 3x. So I'm going to have 5 here, 1 here. So x plus 3, 5x times a -2 So I'm gonna have a 5x plus 3 and an x minus 2 equals 0. So my one x-intercept is going to be a -3/5. Another x-intercept is going to be a 2. So those are my x-intercepts, and my y-intercept is -3. Okay, so for this one, they're asking me to sketch. So if I'm sketching this, my inflection point is at -4, 2. So I'm going to go to -4, 2. -4, 2. And this is going to be a -1. So a +1 would have looked like this. A -1 is going to look like this. So that's what I have. Okay, I have the purple one. And they just are asking for a sketch. And then I want it where it's greater than or equal to. So if I come to this inflection point and I want greater, I want up. So that means I'm going to be on this side. Okay. So I am going to be everywhere over here. And that's my answer. On number 11, we want to write the equation of this. So I need to find my center, which is at 1, -2. So that means I'm going to have an x minus 1 squared plus a y plus 2 squared equals, and now I have to look at my radius. My radius is 2, so I'm going to have a 2 squared, and 2 squared is 4, and that's my circle. On 12, my this is absolute value. My vertex is at 3, -2, and then I need to pay attention to how I'm moving. I'm going up to every one. So this is going to be y equal to absolute value x minus 3 minus 2. And then the last ones are these graphs. So on this one, this is a reciprocal function. And so I'm going to have two asymptotes. One's going to be at x equal 3. One's going to be at y equal 4. So I'm going to get this dashed line here. I'm going to actually use the line tool. Okay. And so I'm going to go to x equal 3. Okay. And y equal 4. So this one here is x equal 3. This one here is y equal 4. And then remember for these, it's really like I'm graphing x, y equal 1, what multiplies to 1. So if I come here, I'm going to go 1 times 1. And if I come here, -1 times -1. Those are the 2 points that I'm going to be accurate with. And then I'm going to sketch the 2 branches. That's one branch. That's the other branch. That's called a reciprocal function. On B, this is a square root. It has a starting point at 1, 3. So I'm going to go to 1, 3. And then from here, I am going to just do square root. So if I go out 1, square root of 1 is 1. If I go out 1, 2, 3, 4, the square root of 4 is 2. So I'm going to go up 2. And then I can draw my square root. And the last one here is an exponential, has an asymptote at y equal -3. So let me draw that in at -3. And again, this is a asymptote. It is a horizontal asymptote, so it's going to be y equal -3. This is saying that I want to go to the right 4, so I'm going to come to the right 4. So go to my asymptote, and at the y-axis, go to the right 4. This is where I'm going to start my graph. Okay, so here I'm going to do 2 to the 0 is 1, okay? Over 1, 2 to the 1 is 2. Go over 2, 2 squared is 4. And then I'm going to draw my graph. And there you go. There's your exponential. So again, you want to make sure you can do these problems without my help. These are here for a reference. Good luck.